We are now looking at measures of dispersion for a simple frequency distribution. So here we have our frequency distribution. We have the age of the students and the number of students, the frequency. So measures of dispersion. Let's do the range first. The range is simply the highest number minus the smallest one. So here we have the highest age is 20 and the lowest is 12. So it's simply 20 minus 12, which gives us a range of 8. Alright, so this is the simplest one. Continuing, we're going to look at our variance. And if you notice the formula, this formula, we have S here instead of sigma, because we're talking about the variance for a sample, not for a population. So S squared, variance for the sample variance. So here goes. Notice we have fx squared. So I'm going to simplify things, and the age would be our x, because that's a variable, and the number of students is our frequency. Alright, so we have x and we have f. So we will need a column to multiply f, the frequency, by the square of the variable x squared, and we also need a column for fx. So here goes. So let's start by just having the total frequency. So in all it's 40 students, so n is 40, same as the sum of f. Alright, so we have n, fx is just the frequency times the variable. So 3 times 12, 36, 7 times 13, 91. And we'll do that for each row. And we'll get an overall total of 610. So the total for f times x is 610. Similarly, we need f times x squared. So frequency 12 times the square of 12. Frequency 3, that is, times the square of 12. Right, 432. Frequency 7 times the square of 13. 1183. And we continue for each row and get a total of 9474. So we now have the summation of fx squared. We have n equal 40, and we have the summation of fx to be 610. So let's go. So we have summation of fx squared, 9474, minus, in brackets, we have the summation of fx, 610, and we square that value, divided by n, 40. Then in the denominator we have n minus 1, 40 minus 1. So we can plug this into the calculator at the top. 9474 minus 610 squared divided by 40. And that gives us 171.5. And 40 minus 1 gives us 39. Then dividing, we get 4.397. So our sample variance is 4.397. Next, the standard deviation. The standard deviation is the square root of the variance. So since our variance is 4.3, oh, we have 4,000. Let me just correct that quickly. Right, so it's a square root of 4.397. And that works out to be 2.0969. So our standard deviation, again, the sample, standard deviation, 2.0969. Next, we have a coefficient of variation. And that's simply the standard deviation divided by the mean. So it will be 2.0969 divided by 15.25. Now the calculation for the mean, we had done that in another video, but it's simply the total for fx, 610, divided by n, 40. Right, that's how we got the 15.25. When we divide here, we get 0.1375, that's our coefficient of variation. Also expressed as a percentage, it will be 13.75%. Of course, to convert to a percentage, we simply multiply it by 100. So, this is our CV, 13.75%, and it's saying that the standard deviation is 13.75% of the mean. So, that's it. We have just covered measures of dispersion for a simple frequency distribution. All the best. We will be in touch.